It's a mouthful, but they were actually were the very first entry submission for the Innovators Corner. Thank you.
Thank you. My name is Chris Galliano. I'm the Director of Military Products at LaserMax. This is Dr. Brian Olmstead. He provides all the brains here. So let's see if we can't get this going. There we go. So I'm just hit it or slide it.
Try both. Just tap it. Tap it. See what happens.
All right. All right, so what we talk about is quantum cascade lasers. The reason that we started looking into quantum cascade lasers over 10 years ago was the fact that we believe that the mid-wave band of sensors and lasers out there are basically one of the only ones that remains covert at this point. The U.S. Army used to brag about the fact that they own the night. Right now they basically rent it, and they're paying a lot of money for it. Most third world countries, including all the asymmetric fighters and everything else, currently are armed or have the ability to be armed with night vision devices, the near IR devices. The long wave thermal devices, which everybody commonly uses, including the United States Army, which has a large ground force of the long wave thermal devices, is also currently basically compromised at this point because of the fact of DARPA's ability to bring down the cost of long wave thermals so that everybody's able to have one basically on your iPhone. Means that all the bad guys can also have them as well very cheaply and very easily. And basically the military has been looking at two different bands to go to for the future. The one is the SWIR, which is the shortwave infrared, and the other one is the midwave. The SWIR is also being compromised at this point with a number of foreign companies and countries out there basically investing their time and energy into that band. In fact, the head of DARPA at one of the night vision conferences stated that the Chinese were actually ahead of us in SWIR at this point. So, and that for us leaves basically the midwave band that's out there. The cooled midwave. Quantum cascade lasers, the technology has been around for a while. We work very closely with the people our growers to be able to get the chips that we need to be able to do this. Quantum cascade laser technology, basically for those that aren't a PhD in optics like Brian, is basically they're taking a petri dish and they're growing these things layer after layer at basically the subatomic level. They take these things, they go ahead and radiate them, they go ahead and what they call cleave them or chop up the chips, and then you basically have very, very small crystals about the size of a pencil lead. And what you have to do is be able to take these things, grow them the right way, add the right amount of electricity, and basically you're going to get a certain spectrum of light out of it. What we do is we harden these chips so that they're able to survive shock, recoil, things of that nature, and we able to put lenses in front of them so that we're able to get beams out of them for both lasers and for beacons. We've done most of this work for ourselves on IRAD, basically of our own company to be able to deal with it. We've done this for over 10 years now. We've done a number of different platforms that we've built and tested, both in some of the TE exercises, the TSOA exercises, as well as some of the exercises basically in experiments that we do on our own all the time. We've done a number of dismounted systems that work with both the next generation of midwave cameras for the sniper systems that are out there. We've done some systems for vehicles and dismounts on those. And we've also done, basically, we have the ability with the beacons for the air platforms that are using the midwave cameras to be able to see these. One of the things that we really specialize in, again, is hardening these systems. What we do is we're able to take the QCL chips themselves, put them on a mount, and basically be able to put them in TO cans and cores, so commercialization is possible for any company that would like to integrate these into their midwave products going forward. Some of the things that we've done as far as capability overmatch is we've been able to provide SOCOM units for testing out there so that they're able to take these units, use them with the existing mid-wave and other out-of-band technology type cameras that are out there, and test them and see for themselves that these are a very viable solution at this point to be able to keep them covert and be able to keep the bad guys from able to see the good guys. We've been able to successfully test these both on rifle-mounted platforms, both for 5.56 and also for the 7.62 SCAR, but also basically for some of the sniper systems like the new PSR sniper rifle. One of the TEs, we were able to get one of our multispectral systems out there, which basically consists of a mid-wave laser, a near IR laser, and a SWIR laser, and we were able to take them and be able to mark targets out there and point them out, targets of interest, at a variety of ranges, basically, for everybody to be able to see. So it's just not an experiment we're conducting ourselves. At TE-14-2 at Fort Story, we were able to take a target of opportunity, which was a ship basically out there on the water. We were able to take a mid-wave camera and use our mid-wave laser to be able to put the spot out there so everybody was able to see it. And let's hope this runs. All right, hit it again.
Yeah, try tapping.
All right, we tapped it.
To run the video, we're trying to. Oh, tapped it. Nope.
Nope.
Go back.
All right. All right, it's back.
Yeah.
Hit it again.
Is this the video page?
Yep.
Oh, maybe you drag cursor down to the bottom left. It might give you the controls for the video.
No.
Back.
Okay, go back.
Yep. Nope. Nope. No, he just cut it off.
Yep.
Technical difficulties.
That's fine. Can you go back? If you have. If you can go back.
I'm trying. I don't have the ability to go back.
Yeah, so there.
Okay, that is one of the mid-wave spots on a human, basically at 900 meters away. Out there, as you can see, the pulsating on the person in the mid-wave. That's basically the spot of the laser at that point. We missed one, right? The Fort Story.
Yeah, you can go backwards maybe.
Trying doesn't go backwards. This next one is we're at 3 kilometers, and this is during bright daylight. One of the nice things about the mid-wave lasers is you're able to use them 24/7, basically, so it doesn't matter whether it's day or night. So as you can see, the spot on the side of the building there, this is done in bright sunlight. You're able to detect where the beam is at 3 kilometers away. The mid-wave beacon that we have, we just finished doing some testing at Camp Roberts last week on that. We've also done some air validation tests with some of the fixed wing assets that are available with some of the new mid-wave sensors, and they were able to see it basically with no problem at a variety of ranges. And that was at 6 kilometers, basically up at Lake Ontario. We're from Rochester, New York. We don't have a lot of hills to shoot beacons from. So we were shooting these over Lake Ontario, and 6 kilometers away, we were able to detect the beacon with no problem, ground to ground. We've been able to do it a lot further, ground to air. We've also, when it comes to QCLs, we've also done testing with long wave chips as well. We've developed some long wave beacons and long wave lasers that work with the long wave markers. Again, one of the reasons we don't do this as much right now is the long wave we believe has been totally compromised by most countries in the world at this point. LaserMax basically is a small woman-owned company out of Rochester, New York. We have a number of great folks up there that build these things for us. We are a woman-owned small business, ITAR certified, and basically we do a lot of experimentation with both the mid-wave and the long-wave lasers and beacons at this point. Questions?
Okay, I'll ask the first question. In your concept of implementation, so we would replace our current beacon and laser systems, but then would we also have to replace all our night vision devices?
No. The night vision sights themselves are great for being able to view and see the night. The problem is anytime one of our soldiers, airmen, Marines, turn on their beacon that they may have on their helmet, or they turn on that laser that's on their weapon system at this point, they're basically broadcasting that that's an American unit. One of the things about the enemy is they've learned to use night vision goggles and thermals, but they don't necessarily use the lasers to go with them. So whenever they detect the lasers out there in those bands, that they know that those are American or NATO forces at this point.
So they're compatible, your technology is compatible with our existing sensors, but not compatible, but on the commercial technology can't find it.
Commercial technology cannot find them. It's only in the mid-wave band itself.
Okay.
So anybody that has a long-wave thermal detector, the people like with the FLIR ones on their iPhones, that
Right.
they can see it. They can see those types of things that are out there now, so that's why we kind of stay away from the long wave. The mid-wave right now, the only real platforms that are out there, there are quite a few in SOCOM, and most of our fixed-wing aircraft can see in the mid-wave.
And you've done all of this with your own internal research and development?
Yes, we've done all this with our own IRAD, with a lot of testing at the TEs and at SOCOM events as well.
Do you have CRADAs with any Army organizations?
So we have had development contracts on some of this. I'm sorry. So the core and the packaging level at the very smallest level has been done all internally funding, but some of our devices have been funded through development contracts with SOCOM and places like that.
And do you have a product available for market today?
Yes, actually we do. We're going to have, we're actually releasing a line of beacons and mid-wave thermal lasers basically this year.
And is their power draw the same, less, more than the existing lasers and beacons?
So you can tell them like the number of batteries.
Okay, so for example, our mid-wave laser at this point takes two 123 batteries, which everybody's familiar with, and will run basically for about an hour straight. The same thing with the beacon at this point.
So is that equivalent to the existing technology?
It's a little bit less than the existing
Okay.
technology, but the fact that you don't have to turn it on and keep it on continually makes it so that they're able to operate through an entire mission.
Okay. Thank you.
Any other questions? Thank you very much.
Thank you, sir. Okay, have we solved the video problem? Let me verify. Okay, what we're going to do right now, we have a technical difficulty, not with the presentation, but with our YouTube feed, and it's YouTube, not our guys. So we're going to take a 15-minute break, and then we'll start up. I apologize for YouTube.